Hello and welcome to another episode of Polynomials and what we're doing with them. Right now we're going to begin on synthetic division. Now, for those in my classes, we've already taken a look at this, but we're going to step back a little bit so we can jump back into this and stay in step with the other classes. And to Crawford students, hello. So, it says, what is the result when 3x cubed plus 13x squared plus 19x plus 9 is divided by x plus 1? And for this first example I'm going to show you, I'm going to just go to the solution and then step by step it from there. So we have to make a box. We multiply by -1 diagonally and by the columns vertically. The -1 actually comes from we flipped the sign on the coefficient or on the constant term of the linear factor we're dividing by. So we turn that +1 into a -1, and the rest of them we just stuck in our box. We multiply diagonally and stick the numbers down to the right. And we are going to actually do this manually, so you'll see how we got each of those numbers. We're going to do a full screen snip here. And we're going to go ahead and, given that box, we're going to say, I'm going to make the box brown, make this for the remainder. And what's another good color? Oh, orange, great idea. So we've got x plus 1. We're going to take this +1 and turn that into a -1 here. And we have our polynomial. This is already pretty much given by the example, but this will help. And then 19x plus 9. And we get 3, 13, 19, 9 right here. Oh, my mistake. I should write these up here. And now what we're going to do is we're going to multiply the 1 by the 3 and place it here. Actually, the first thing we need to do is just bring the 3 straight down. And then we multiply -1 by the 3 that we're left with down there and get -3. Then we add these together to get positive 10, my mistake. And then we multiply -1 by 10 to get that -10 that we see over here. We add these up to get 9. -1 times 9 is -9, and we get 0 in this final thing when we add down. So now we simply place in powers of x alongside these numbers. I'm going to make these blue. And starting with the constant term here, we don't place an x there. We place an x here, and then we place 2 x's here, so x squared. And then we simply add everything together. And then here, this is where a remainder term would go if we had something left over. And we'll show you that on another example. So I'm going to go ahead and, since that gave us this, we got 3x squared plus 10x plus 9. We're going to plug that in, and then we're going to take a look at a slightly more in-depth example. So 3x squared plus 10x plus 9. Drop my pen. And let's check out level 2. So we have, what is the result? We divide this by x plus 3. So this changes a little bit. Now we're actually getting a just one number here. So we're going to go ahead and do another screen sketch after I zoom in a little bit. And we will see what we can do and if we get it right. So let's make that box again. Let's zoom in. We have 3x to the 4th, 17x cubed, 26x squared, 10x, 12, and x plus 3. So now we can go ahead and make our box. So our numbers are going to be -3 because we changed the sign on this. And we just bring all these in. 3, 17, 26, 10, 12. Also, I should probably note that these are all added together in that polynomial. So the first thing, again, we bring down the 3, and we get that in our answer. And then we start doing the multiplication. -3 times 3 is -9. -9 plus 17 is +8. -3 times 8 is -24. Adds up to 2. -3 times 2 is, you guessed it, -6. These guys, my mistake, these guys here add up to +4. And now -3 times 4 is -12. And those guys add up to 0. So again, we don't have a remainder, but now let's start plugging in values of x. X, remember this one gets no x's. This one's going to be an x squared. This one's going to be an x cubed. And then we just add them all up. So 3x cubed plus 8x squared plus 2x plus 4. And no remainder. Plus 8x squared. Perfect. We got that one right as well. So let's do one more of these examples, and then I'll have you do a couple. So what's the result whenever this guy is divided by that guy? Let's go ahead and do exactly that. Let's go to here, and we're going to get another screen sketch. So it's going to go to classic black pen. X cubed minus 6x squared plus 3x is going to be 1, -6, 3. And we're dividing it by x minus 5. Change the sign on that 5 to get +5 here. And now, again, we start by bringing down the 1, and we get 1 here. 1 times 5 is 5. That adds up to -1. -1 times 5 is -5. That adds up to -2. And then -2 times 5 is going to give us... Oh, also, I actually left out something important here. When we have something that is missing, like a constant term that's not there, that should be +0. We need to consider that to be a 0, so it's a fourth column. And that's something I certainly should have started with, but I forgot. We all make mistakes. 5 times -2 here is -10, and that's going to end us up with -10 in this place. So in a minute, we're going to see what actually needs to go here. We're going to plug in our powers like usual. We've got an x squared. So that actually is going to be able to simplify to x squared minus x minus 2. But now we have this -10 over here. What are we going to do with it? We're going to divide that by x minus 5 because it doesn't go in there neatly. That's going to give us -10 over x minus 5, because if we had something that was like 10 less or 10 more, then we would actually have a divisor and it would factor out completely. But now we're going to need to include that remainder term. So x squared minus x minus 2 minus 10 over x minus 5. Perfect. So here we're going to watch this. We have exactly what we said. Bring down the 1, -1, -2, -10. And then we stick that -10 on the other side of our remainder line on top of our dividing term here. And the last thing is you've got to remember that 0 whenever we have them. So finally, now that we've done all this, you copy down all the stuff that I did. It should all be written in the video. And you also do one example on this. Let's say, solve this example on your own using the same method. Solve this example on your own using the same method. And solve this example on your own using the same method. So y'all, thanks for tuning in. Have a fantastic whatever day of the week it is that you're actually doing this, and I will see you soon.